Kia ora koutou. This question is one that we started to look at in class on Friday in 12 MAS. So I'm doing this video for Veeti and I've chucked in another example to give you some practice. Remember that what we're using right through these equations where I've got x in the powers is my log rule, the one that goes the log of a to the power of b can be rewritten as b times the log of a. So I'm going to use that in here. Remember, when there's no base given for a power, we usually mean that it's base 10, but it doesn't matter. We could have any base here at all, and it will work in the same way. I'm not going to go through again why that is now, but let me know if you want to understand that a little bit better. Okay, so in this whole video, there won't be any bases for the logs. And if you're doing it on your calculator near the end, you're just going to use the log button, which is implicitly the log to base 10. All right, let's look at the first one. So we've got 3 to the power of 2x minus 1 is equal to 7 to the power of x plus 2. Now, before I go any further, I want to just check that there's nothing simple that I can do with these bases. For example, if instead of 7 here, I had 9, I wouldn't go through all of this method that I'm using. I would instead change 9 into 3 squared and work from there. But there's no easy link between the 3 and the 7. So what we're going to have to do is take logs of both sides. So that's the first step. The log of this side is equal to the log of this side. And if I wanted to, this would be the point to put the brackets in around the power. Okay, so now I'm going to use this log rule up here on both sides. And on the left-hand side, I get 2x minus 1 times the log of 3 equals x plus 2 times the log of 7. Now, back up here, it was pretty much optional to have those brackets in there, but it's crucial that you've got them in here now because we're saying that the log of 3 is getting multiplied by all of this here. So we have to have those brackets around those factors, otherwise things are going to go wrong. Remember that log 3 is just a number. So I can expand this out like we did back in year 9, and I'm going to get 2 log 3 x minus log 3, and on the right hand side I get x times log 7, which is log 7 x plus 2 log 7. What we want to do is to solve to get a value of x, just like we did back in year 9. And this strategy is exactly what it was back in year 9. So remember, if I had an equation like, I don't know, negative 3x minus 17 equals 602, I wanted to get the x stuff onto one side and the number stuff onto the other side. And that's the same thing now. Okay, so I'm going to isolate all of the terms with x on one side. So this has got an x in it, and this has got an x in it. This bit is just a number, and this bit's just a number. So I'm going to subtract this from both sides, and I'll have 2 log 3 times x minus log 7 times x is equal to 2 log 7 plus log 3. And on the left-hand side, we can factor out the x, and we get x times 2 log 3 minus log 7 is equal to 2 log 7 plus log 3. So I've got x times a thing is equal to all of this. I'm now going to divide both sides by this term here, and we'll be done. So x is equal to 2 log 7 plus log 3 divided by 2 log 3 minus log 7. Now that's what we call an exact answer, but it's not much use for giving you a feel for what the number is. So this is where we're going to grab the calculator and we're going to work out what the numerator and the denominator are. So for the numerator we get something like 2.167317, and for the denominator we get 0.019144. And I'm going to divide one by the other, and my final answer here will be 19.86, and I've just done that to 2 decimal places. Okay, so that's that first question done. I'm just going to do a couple more things with this question while we're here. Sometimes in level 2 we'll be asked to write things as the log of a single number. So I'm going to practice writing both the numerator and the denominator as the log of a single number. So think of this as a separate little question. So that 2 log 7 we can write as the log of 7 squared plus the log of 3. And the 2 log 3 we can write as the log of 3 squared minus the log of 7. Now remember, we've got these log rules. Log of AB is equal to the log of A plus the log of B. I'm going to use this version to go back to here in the numerator, and in the denominator, remember that the log of A over B is equal to the log of A minus the log of B. So I can clean this up a little bit more. This is equal to the log of 49 times 3, right, using this rule here. 49 times 3 gives me 147, divided by the log of, so here I've got 9 over 7. Right, so that's my final answer there. Just remember that I can't do anything to combine these two logs, okay? That's not what my rules are telling me. So this is the rule that I can use on the denominator because I've got a minus sign here. All right, now I'm going to go back to the start of the video, and I want you to pause the video and now have a go yourself at doing that second equation before I go through it quite quickly. Just notice again before we start that we're looking at our bases. We've got 4 and we've got 9, and you hopefully will spot that 4 is 2 squared and 9 is 3 squared, but that's still not really going to help us get a common base. So in this one, again, you're not going to muck around with changing the bases. You're just going to get on with taking logs of both sides for your first step. So pause the video and try and work the whole way through it, and all the way through to a really ugly decimal answer for x. Okay, so let's go through it. 4 to the 7x minus 2 is equal to 9 to the power of x plus 3. Take logs of both sides and use the power rule. So we get 7x minus 2 times log 4 is equal to x plus 3 times log 9. Expanding gives me 7x log 4 minus 2 log 4 equals x log 9 plus 3 log 9. Okay, so which ones of those are just numbers? Well, that's just a number. That's just a number. That's got an x in it, and so's that. So we want to isolate all the stuff with x's on the left-hand side. 7x log 4 minus x log 9. And now we're going to add this to both sides. So we have is equal to 3 log 9 plus 2 log 4. Factorize out the x in here, and you'll get x into 7 log 4 minus log 9 is equal to 3 log 9 plus 2 log 4. So our final answer, our exact value, is that x is equal to 3 log 9 plus 2 log 4 divided by 7 log 4 minus log 9. And when we bung that into our calculator, we're going to get out, in the numerator we'll have 4.0668848. I'm writing all that out because this is one place where small rounding things actually do make quite a big difference, because it's going to end up being a power, right? And so it will have a big impact. So in here, when I do that, I get 1.247431. Now, I wouldn't usually say to go to 6 decimal places, but when I check this back, if I round it even to 3, because we're working with really big numbers, we ended up a few numbers off. So what we can do now, so that's my final answer for x. We can check it back, and we're going to go 4 to the power of 7x minus 2 is going to equal 4 to the power of 7 times 1.247 ... minus 2, and that gives me almost exactly 11,300. So I got this, and now I can check on the other side. 9 to the power of x plus 3 works out to be 9 to the power of 4.247 blah blah blah, and that works out to be 11,300.02. So you can see that it all works out, but just watch out for your rounding. Thanks very much for watching, and email me if you've got any more questions like this that you'd like me to YouTube.